Today we're going to talk about key features of graphs of linear functions. So the key features we're going to be looking at are primarily the parts that are involved in the slope-intercept form of a linear equation. Slope-intercept form is y equals mx plus b. M represents the slope of the line, and b represents the y-intercept. Okay, now the y-intercept is where the line crosses the y-axis. So the y-intercept is right here. My y-intercept, or b, is 0, 6. When I write down my y-intercept, I always write it as a coordinate. So when I think of it as the y-intercept is the address, and the slope is the directions. Okay, so the y-intercept tells me where I start graphing, and the slope tells me how I'm going to move to get to the next point. So the slope, whenever we work with graphs, our slope is always going to be rise over run. We try to write things as fractions so that our rise, we want them to be in rise over run format. Okay, so the first thing I saw there was my y-intercept, which is right there at 0, 6. If that's the y-intercept, then this point right here at 4, 0 is my x-intercept, which we also call a 0. That point is located at -4, 0. Now, I've thought of a lot of really dumb ways to think of how you can remember what's 0 and what's not. The best way I can think of, my last name is Deal, my husband's last name is Deal, my daughter is a Deal, my father-in-law is a Deal. We're all Deals because our last name is Deal. Well, this 0's last name is 0. That's how you know that it's a 0. I mean, it's a dumb, but whatever. If you think -4, 0, its last name is 0, then it's your x-intercept. So there's that. I can use these 2 points. When I look at this x-intercept, it has absolutely nothing to do with my slope-intercept form of a linear equation in terms of it's not the intercept that I put here, but I can use these 2 points to find my slope. So my slope is going to be m, which is rise over run. So to get from this point to the other one, I'm going to rise 1, 2, 3, 4, 5, 6. And I'm going to run 1, 2, 3, 4. So 6 over 4. We can reduce that to 3 over 2, which would be the slope that we would use for this equation. So now if I want to write this in slope-intercept form, I would write y equals slope, which is 3 halves x, plus my y-intercept, 6. Now if you wrote y equals 1.5x plus 6, that's totally right. There's nothing wrong with that. Now 6/4 x plus 6, you'd have to reduce that. If you wrote 1.5x, that would be fine. But when we're writing stuff when we're graphing, we kind of like to leave things as fractions because it's easier for us to graph them when it's in rise over run format already. All right, so we did a whole bunch of examples, and we're going to do these. I'm going to do these examples with you again. Let's see if I can zoom in a little bit. Nope, wrong way. Okay, so with this first one. When I look at a table to find my y-intercept and my slope, remember my y-intercept starts with 0. So here is my y-intercept. My x-intercept has a last name of 0, so that's my x-intercept. So I know my y-intercept has an address of 0, 4. My 0 or x-intercept has a address of 10, 0. I can use those 2 points to find my slope. Now, we talked on the last problem about whether something is about the slope. This is negative slope. The way that I remember this is there's something that one of my coworkers used to do where she would draw mountains. I found that confusing. So what I do is I draw a little guy standing on top of the line, and he's like pointing, and he's always pointing right because we read from left to right. Is he pointing uphill or downhill? If he's pointing downhill, that means I'm going to have negative slope. So when I work through my rise and run, I should wind up with a negative answer. Okay, so I'm going to start my rise over run. I always write rise over run. Then I'm going to rise 1, 2, 3, 4, negative 4, because I'm going down 4. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to run 10. That reduces to negative 2 fifths. So my equation is y equals negative 2 fifths x plus 4, because b is my y-intercept. Now let's look at this one. Now this one doesn't have a constant or y-intercept listed. So if you want to, you can write 3x plus 0, just to kind of help you keep straight. Since we're trying to identify these key features, if I know that my y-intercept is 0, that means its address is 0, 0, which is the origin. So that means I'm going to start graphing my points at the origin. And when I look at the slope, my slope is 3, but that's not written in rise over run format, so I'm going to turn it into rise over run format by writing it as a fraction. In order to turn a whole number into a fraction, I write it over 1. So now, in order for me to find to draw the line of this equation, I'm going to rise 1, 2, 3, run 1, put a new dot. Rise 3, run 1, rise 3, run 1. And then if I wanted to, I could continue that pattern back in the other direction. Now this is not part of this current unit, but if I look at this data, even though I've plotted dots, I still, every time I plot a graph, I have to decide whether or not I'm going to connect the points or not. I have to decide whether or not this is discrete or continuous. The way I decide whether this is discrete or continuous is I look at the situation. Oh, what, you say there's no situation? Then it's continuous. If you don't have a situation, you've got continuous data. In addition, your domain and range are all real numbers. Since this is a linear equation, your domain and range are going to be all real numbers, so we put arrows on the end. Without a situation to limit this, we have to give this free range. It has to be able to do anything we want with it. Okay, so just as a side note. When I look for the x-intercept, I'm looking for where it crosses the x-axis. Well, it also crosses the x-axis at 0, 0. Okay, let's look at number 3. Number 3 says the line passes through -3, -9, and has a slope of 5. So this time they didn't give me the y-intercept, they didn't give me the 0, but they gave me the slope and a point. And just like I do with the y-intercept, I can use any point to start graphing points on my line. So I'm going to plot -3, -9, and then I'm going to look for my slope. Again, it says my slope is 5. I need to turn that into rise over run. So that's going to be 5 over 1. That means I'm going to rise 1, 2, 3, 4, 5, and run 1. Place a dot. 1, 2, 3, 4, 5. Place a dot. 1, 2, 3, 4, 5. Place a dot. I like to plot everything I can. And again, is there a situation? No, there is not. So I have continuous data, and I can connect my points. So I can see right here where my y-intercept is. It's at 0, 6. And I can write an equation right now. Y equals 5x plus 6. But when I look for my 0 doesn't land on a whole number coordinate. So you could answer this one of two ways. The first way you could answer is you could say my 0 is between -1 and -2. That may not be good enough. If it's a question where you have to use a bubble grid or they're expecting a precise answer, you're going to have to substitute to find the answer. So I'm going to take my equation. I know that a 0 is something comma 0, and that's x, y, so I know that my y value is going to be 0 in that coordinate. So I'm going to take, everywhere I see a y, I'm going to substitute a 0. So I'm going to do 0 equals 5x plus 6, and I'm just going to solve this thing. -6 equals 5x, divide both sides by 5, and I get -1.2 equals x. That means my 0 is -1.2, 0 is the coordinate, the specific precise coordinate of it. If it's a multiple choice question and there's only one answer between -1 and -2, you don't really have to do this step. If they're requiring you to give a precise answer, this is a step that you're going to have to do, and we will do more of this tomorrow. If you look at number 4 here, number 4 has 3 points. So they gave me 3 points. I'm going to plot these 3 points. -6, -2, 0, -1, and 6, 0. Okay, again, no situation makes my data continuous. All right, I know that's not the best line, but let's just pretend it is. Okay, so I know my x-intercept. My x-intercept is my 0 here, 6, 0. My y-intercept is right here, 0, -1. Now I just got to figure out what my slope is. So my slope is rise over run. So I have to rise 1, run 1, 2, 3, 4, 5, 6. Okay, so my slope is 1/6. That makes my equation y equals 1/6 x plus -1. Now technically that is a correct answer. There is nothing wrong with that answer, but that's just not how we write it in algebra. You will almost never see an answer written like that on a test, on a multiple choice answer, in a book. This is just not how we write them. So while you will not lose credit for writing it like this, I'm going to encourage you to write it like that, as y equals 1/6 x minus 1. Like I said, this is not wrong. It's just that's not how we do it in algebra. So get used to writing it this way. That's going to be better for you. Let's look at these last two problems. Now, these are word problems. So it says, based on the graph below, identify the key features and describe what they mean in the situation. What situation, you may say? There's no word problem here, but they give us a lot of information just on the axes. They say number of cupcakes and balance remaining on gift card. So what that tells me is somebody's buying cupcakes with a gift card, which is awesome, because who wouldn't want to do that? Now, when I look, I can also tell they started with $30 on their gift card. That value happens to also be my y-intercept of 0, 30. I can also see that this is discrete data because I have dots plotted. If I think about it, I also know that it's discrete data because, I mean, I can eat half a cupcake, but I can't buy half a cupcake. They're not going to sell me half a cupcake. And why would I want them to? I would not. So this is discrete data, both because I have dots plotted and because the situation calls for it. I have a 0 here also at 12, 0. And that, if I just read what it says, 12 cupcakes, $0 on card. So what that means is I can buy 12 cupcakes before I run out of money on the card. You have to be able to interpret when you have a situation. That's one of the things that we're really focused on in algebra, is making sure we understand what every single aspect of the problem means. The only thing I need to find now is the slope. I know I've got negative slope because my little dude is pointing downhill. I also know I know that I'm running out of money. So I know everything is getting smaller and smaller. So let's look at my slope. I have my rise over run. I'm going to fall 30, and I'm going to run 12. Is that right? Yeah. So negative 30 divided by 12 gives me negative 2.5, which if I get my math enter on, gives me negative 5 over 2. Now, if I'm just thinking about graphing this equation, then the equation I would write would be y equals negative 5 over 2x plus 30. But if I'm thinking about the real world situation, I'd probably write y equals 30 minus 250x, because I have $30 and I'm spending $2.50 each cupcake. So sometimes your equation is going to be different. We don't always leave them in rise over run format, especially if we have a situation that calls for us to make sense of what those numbers mean. The last problem we have here says, suppose the water level of a river is 14 feet. It's increasing at a rate of 1.5 feet per day. We can start by putting a dot at 14 feet on this graph, and then we can rise 1.5. Okay, I'm already not liking this 1.5 thing because my little dots here go up by 2. So I'm going to start by writing myself an equation. Y equals 14 plus 1.5x, or y equals 1.5x plus 14. Both of these equations are right, but I'm going to encourage you to start writing it like this second one for one simple reason. We write things, the format you know is y equals mx plus b. You're going to be able to say this in your sleep by the end of the year. When you don't write it in mx plus b format, a lot of times what you'll do is you'll say the first number's m, the second number's b. That's not the case. The number you multiply your variable by is m. The number by itself is b. But a lot of times you just get so used to doing it that way by default that you forget. So I'll encourage you to write in mx plus b, but this is absolutely right. You won't lose points for this. You just got to be really careful when you write your equations like this. So my y-intercept is where I start is 0, 14. My slope is 1.5. Well, I want that in rise over run format, so I'm going to just put 1.5, math, enter, enter, and it turns it into 3 over 2. Look, if you can figure out that 1.5 is 3 over 2 without using your calculator, I'm not saying you can't, but if you don't know how to do it by now, you need to use your calculator. All right, so 3 over 2, that means I'm going to rise 1, 2, 3. I'm going to have to go halfway, run 2. 1, 2, 3, run 2. Remember, I'm going up 1.5 because each of these little spaces is worth 2. And I'm just going to keep on going. And then we keep on plotting. We plot some more, we plot some more, we plot some more. Now, I ask myself the same question I always ask when I'm graphing a situation. Is this data discrete or continuous? Well, I have water level rising at a rate of 1.5 feet per day. That's continuous data. Both height and time are continuous. So I'm going to connect the line. Now, I'm probably not going to put an arrowhead. I could, but I mean, it's not going to go on forever. There will be an end to this water rising. Eventually, the water will reach the top of the, I mean, if the water kept rising forever, then the water would eventually, it would go over all the earth, and it would go over the mountains. It would like reach into space, and then it would take over our solar system and the galaxy and the universe. And that's just not going to happen. That's not realistic. Eventually, the water's going to stop rising. So we would say to a reasonable value on this one. Okay, so I'm satisfied with this. I'm satisfied with the equation. The only thing I'm not satisfied with is the zero. So if I actually put this in and figure out what the zero is, I get negative 14 equals 1.5x. Divide by 1.5. 14 divided by 1.5 is 9 1/3. Negative 9 1/3 equals x. So my zero is negative 9 1/3, 0. We've talked about how the real world happens in quadrant 1 all the time. This 0 does not make sense for my situation, because it's happening all the way over here in quadrant 2. That would mean I would have to go back in time several days. I'd have to go back in time 9.3 days before there was no water in the river, and that just doesn't make sense. It's not like the water, and then that would also suggest that I could go even further back and that there will be negative water. What does that even look like? So not only does my zero, in some cases, there is a zero, but it doesn't match the situation.